This is memory based paper of 24th January, shift 2. Let us see the questions of this paper. The first question is asked on metallurgy. This is the metal which is extracted by oxidation and subsequent reduction of its ore. The options are given. First one, gold. Gold, we know that it is extracted by cyanide process, where it is leached with cyanide solution in presence of O2. That forms a complex AuCN2 minus, which is further reduced by zinc to give gold metal. Now we can see that in this process, cyanide is acting as complexing agent and O2 is acting as oxidizing agent. So zinc is acting as reducing agent. So overall we can see in this extraction of gold, oxidation by O2 and reduction by zinc are involved. Therefore, the gold extraction involves both oxidation and subsequent reduction. Now if you see the other options, copper is extracted mainly from the chalcopyrite, which is subjected to partial roasting, which will give FeO, Cu2s, and some of the Fes remained as unreacted. The FeO formed react with silica to form slag FeSiO3. So we'll get what? Copper matte. If you can recall, copper matte is formed, that is Cu2s and Fes, which further react with O2, which is further partially roasted to give Cu2s. The leftover Cu2s on further heating with Cu2O gives copper liquid, which we call it as blister copper. So in this, roasting and reduction is involved, self-reduction is involved. Extraction of iron involves concentration and the reduction by carbon. So chief reducing agent here is carbon monoxide. Carbon monoxide reduces Fe2O3 to Fe. So Al2O3, aluminium extraction is done by bauxite, using bauxite. Bauxite is subjected to leaching. So finally we'll get pure Al2O3. That Al2O3 is subjected to electrolysis in fused state using the carbon electrodes. You'll get aluminum at cathode. So this is a good question, repeated question. So gold is correct answer for this question. Next question is the number of unpaired electrons present in highest occupied molecular orbitals. Highest occupied molecular orbitals, we should count the number of electrons, HOMO. Now if you take nitrogen, N2 gas, it is 14 electrons. We know that nitrogen, we should write sp mixing, N2 plus sp mixing, O2 there is no sp mixing, and O2 plus there is no sp mixing. When we write the molecular orbitals, we will get sigma, sigma star, sigma 2s, sigma star 2s, pi 2px, pi 2p, and pi 2pz. If you fill the electrons, we are getting here sigma 2pz, we have 2 electrons, and if we remove 1 electron in N2 plus, that is removed from the sigma 2pz, there will be 1 electron here, and O2, it is pi star 2px1 and pi star 2py1, and O2 plus it will be pi star 2px1 and pi star 2py0. Here there are number of unpaired electrons they have asked. So unpaired electrons in N2 is 0, N2 plus it is 1, and O2 it is 2, and O2 plus it is 1. So 0, 1, 2, 1. So this is a simple question, repeated question. You just understand what is HOMO. HOMO is highest occupied molecular orbital. Electron is removed from HOMO or LUMO here. So number of unpaired electrons will be different. The next question, very simple question based on de Broglie wavelength. It is asked the alpha particle, proton and electron have same kinetic energy. What is the order of wavelength? So we know that de Broglie wavelength lambda is h by mv, this which can be written as h upon square root of 2m kinetic energy. As kinetic energy is same, you can write lambda is inversely proportional to mass. All you know that mass of alpha particle is more than proton is more than electron. So we can conclude that more the mass, less is the wavelength. So wavelength of electron is more than proton is more than alpha particle. The next question, it is directly taken from NCRT statements. So this is benzene is more stable than hypothetical cyclohexatriene. That means we are writing resonance hybrid in first case benzene. Cyclohexatriene means we are not considering the delocalization of pi electrons. So as we know that the delocalization leads to stabilization. So benzene is more stable than the hypothetical cyclohexatriene where the resonance is not considered. So this is a correct statement. So the delocalized pi electrons cloud is attracted more strongly by the nuclei of carbon. This is obviously correct. If it is not tightly or strongly attracted, it won't be more stable. As it is delocalized electron cloud is more stable, that should be strongly attracted by the nuclei. So this both statements are correct. And this delocalization of electron which leads to strong attraction with the carbon and stabilizes the benzene. Therefore this is also correct statement and explains this statement 1. So you can see that this is a correct, both are correct statements and reason is correct explanation of this statement 1 given. Next, so this is a titration of benzoic acid and sodium hydroxide. Conductometric titration is given. It is asked what is the plot between conductance and the volume of sodium hydroxide added. So as we know that benzoic acid is a weak acid. As it is a weak acid, it dissociates slightly to give benzoate ion and H plus ion. So initially when you start the titration due to sodium hydroxide addition, the H plus ions which were there due to the slight dissociation of benzoic acid will get neutralized by sodium hydroxide. As a result, we know that in aqueous solution, H plus has the highest conductivity. Due to this consumption of H plus ions, initially the conductivity will decrease slightly. So after this H plus consumption, when you neutralize the benzoic acid, it forms a salt, that is sodium benzoate. Sodium benzoate is formed to give benzoate ion as well as sodium ion, benzoate and sodium ion. So we can see that on adding the limited quantity of sodium hydroxide after this H plus ions consumed, first as the conductivity will be decreased slightly, then further addition of sodium hydroxide converts the undissociated benzoic acid molecules into dissociated the ions, salt. So which leads to increase in number of ions in the solution and conductivity will increase. So after the complete consumption of this benzoic acid, if further sodium hydroxide is added, what is going to happen here? We know that among the anions, again OH minus will have the highest conductivity. Due to large conductivity of OH minus ions, again the conductance is observed to be increased, but that increase will be slightly more than the benzoate and Na plus ions due to formation of Na plus, formation of addition of OH minus ions. Now the next question is based on qualitative analysis, very easy question. Potassium dichromate paper acidified with dilute sulfuric acid, which is turned green. It is turned green due to redox reaction. In redox reaction, dichromate act as the oxidizing agent. This oxidizing agent react with a reducing agent like SO2. So SO2, it will react to produce chromium plus 3 green and sulfate will be produced. So the correct answer is sulfur dioxide gas. The next question is asked based on the acidic strength, most easily deprotonated. So when you remove the acidic proton, you will get this carbanion. Here the carbanion, we can write the different carbanion. Now we know that if the conjugate base is more stable, more stable conjugate base, more is the strength of the acid. Here in all the cases resonance is there. Here also resonance is there. Conjugate base is stabilized by resonance in all the cases. But there is difference in the stabilization due to resonance. We can see that in first two options there is cross conjugation. The OCH3 is involving in the resonance with this CO group. As a result, this C minus extent of delocalization will decrease compared to the others. So now we can write the stability of order of this conjugate bases 1, 2, 3, 4. 4 is least stable because it is stabilized by only one carbonyl electron withdrawing nature. Whereas in other cases it is stabilized by two withdrawing groups. We know that COCH3 and COOCH3. COOCH3 is less electron withdrawing due to cross conjugation. So stability we can write that 4 is less stable than 1. 1 is less stable than 2. 2 is less stable than 3. Because in 3 it is more stabilized by resonance and cross conjugation is not there. Therefore, so the most stable conjugate base is found by the C option, so it is more acidic. If you go for the next question, it is asked that statement 1, beryllium plus 2 has higher SRP than other alkaline earth metal. Higher SRP means beryllium plus 2 will be getting reduced to beryllium easily. So that means the reduction of beryllium plus 2 to beryllium is easy, whereas oxidation of beryllium to beryllium plus 2 is difficult compared to other second group elements. So oxidation of beryllium involves in aqueous solution sum of ionization enthalpies IE1, IE2 and atomization. So beryllium should be first converted to beryllium gas. Beryllium gas should be converted to beryllium plus 2 gas. Then beryllium plus 2 gas should be converted to beryllium plus 2 aqueous solution. Here 3 steps are involved. One is sublimation or atomization and ionization IE1 plus IE2 and delta H hydration. Now we can see that this is the only step which is exothermic hydration, ionization, and now as the size of the beryllium plus 2 is smaller, it is getting hydrated to large extent, and due to the small size and large strong metallic bonding, beryllium has highest enthalpy of atomization. Now this statement is also correct. So hydration energy and atomization energies are more for second group than other alkaline earth metals. Now we can see that higher SRP of beryllium. What is the causing beryllium to have higher SRP? Beryllium is getting converting to barium plus 2, though there is large negative hydration enthalpy, but due to its high atomization energy and ionization energy, oxidation of beryllium to beryllium plus 2 is difficult. Therefore, compared to other elements, it has less SOP because oxidation is difficult, and more SRP is observed. So both statement 1 and 2 are correct. Now if you go for the second question, it is a simple question, routine question asked based on hydroboration oxidation and oxymercuration demercuration. So alkene is reacted with diborane. We know that diborane adds on alkene to form alkyl borane. So boron adds on the less hindered carbon. Hydrogen adds on the more hindered carbon to give alkyl boron. On further oxidation, the boron is changed to the borate salt and the other alkyl part changes to alcohol. This is very routine question. And the alkenes reacted with HgOAc twice. Oxymercuration, demercuration, HgOAc first lose acetate ion, giving HgOAc plus and CH3COO minus, which is attacked by the alkene to form three-membered intermediate, which is cleaved by water. So it is cleaved by water to give this type of intermediate again. So water will attack here. We'll have HgOAc here. HgOAc. In next step, NaPH4 reduces this species into the mercury and this intermediate get converts to corresponding alcohol. So now we can see that the product is formed due to Markovnikov addition in first case, then second case. In first case it is formed due to anti-Markovnikov's addition of water molecule. Therefore we can see the first option here, OH should be there, this molecule, and in second OH should be here, the first option. Next question is based on the environmental chemistry. This is from lines of ncrt given in environmental chemistry. Average human being requires nearly 12 to 15 times more air than food. So you can read the ncrt for such questions. The next question is, aniline and other aryl amines are usually colorless. This is a correct statements. This is again based on the ncrt physical properties of aniline. Aniline and aryl anilines are colorless, but often they appear to be colored due to the atmospheric air oxidizes them into the quinones or imines. So that leads to the color of the compound. The quinones will be dark colored. Therefore, the oxidation of aniline and aryl amines leads to the dark color of the substances after long storage. So both statement 1 and 2 are correct. Anti-fertility drug, it is norethindrone. Antihistamine, Seldon or terfenadine. Tranquilizer, meprobamate. Antibiotic, penicillin. So direct question from ncrt. Now the next question is, it is asked which is good oxidizing agent. Lanthanides. We know that lanthanide stable oxidation state is +3. So any other oxidation state +4 or +3, +2 are not stable with respect to +3. If +4 oxidation state lanthanide is there, that readily reduces to lanthanum +3. Therefore it is acting as oxidizing agent. If any lanthanum +2 is there, that will be converted to lanthanum +3 readily. Therefore it will be a reducing agent. So the +4 oxidation state lanthanides will be acting as oxidizing agent. The next question is based on liquefaction. Liquefaction of the gases. Now here a real gas is there at point A. The pressure on the gas is increased. Then the liquefaction of B starts, gas starts at point B, and there is the equilibrium between the vapor and gaseous liquid phase. And on further application, here C liquid is converted to gas. On further application, there is small change in the volume. So it is a simple question, routine question. Formation of liquid starts at point C, wrong. So it is starting at point B. Formation of B to B and C. From point B and C, amount of liquid decreases, wrong. Here starts and the amount of liquid will increase as we go along this curve. This is wrong. Formation of liquid starts at point B, correct. The point B and C, at this point B and C, there is equilibrium. There both liquid and vapor will coexist. The next question is from coordination compound CONS363 plus. What is hybridation and the magnetic moment? It is again commonly asked question generally. Cobalt plus 3, we know that it is 27 atomic number. Cobalt plus 3 will be having 3d6 electronic configuration. So with cobalt plus 3, ammonia is strong filled ligand and pairing of electron takes place. Now when the electrons are paired from this 3d within the 3d orbitals, it leads to the all paired electrons, 3 pairs of electrons, and 2 orbitals of the d orbitals of cobalt plus 3 are vacant, which involves in the d2sp3 hybridization. So as a result, we can see that it is an inner orbital complex. And as there are no unpaired electrons, it is diamagnetic in nature. So the next question is, H2O2 behaves like reducing agent in which of the following reactions? Reducing agent is asked. Fe plus 2 here is changing to Fe plus 3. It is oxidizing agent. So H2S is changing to sulfate. Here also it is oxidizing agent. HOCl, Cl is plus 1 changing to minus 1. Here it is behaving as reducing agent. Here Mn plus 2 is changing to Mn plus 4. Here it is oxidizing Mn plus 2 to Mn plus 4. So reducing agent in the third reaction. The next question is asked, what are the monochloro products when this compound is treated with Cl2? Now there are only 2 different hydrogens, this here and here. If you write any other product, that you'll get identical structure. So when you monochlorinate here on this carbon, you'll get this product. It has no stereoisomer, so 1. But when you monochlorinate on this position, you'll get this product. It has a chiral center, so this compound is optically active. 2 isomers are formed, enantiomers. So total products formed will be 3. Now it is asked, lactic acid is given. It is asked, what is the pH of the lactic acid salt, anionic form of the lactic acid? That means we should take salt of the lactic acid. Now lactic acid salt, generally if you take with a strong base with sodium, it is salt of weak acid and strong base. So pH will be more than 7. You can apply the formula directly, or you can write the hydrolysis steps and calculate KH, where KH equal to KW by Ka, that is equal to CH square. So where you can calculate KH and H from this expression, you can calculate the concentration of H plus, you will get the pH, or you can apply directly formula pH equal to 7 plus half of pK plus log C. Everything is given here. pK is 5. When you substitute this, you'll get 8.35. So you should approximate to nearest answer. Next, sum of pi bonds in a molecule of peroxydisulfuric acid and pyrosulfuric acid. You know that peroxydisulfuric acid H2S28O8, pyrosulfuric acid H2S2O7, very common molecules. Here 4 pi bonds are there. Here also there are 4 pi bonds. Sum will be 8. The next question, an ideal solution containing XA, A and B are there. A and B. Mole fraction of A is given 0.7. Mole fraction vapor pressure is given. Mole fraction of B is given 0.2. Vapor pressure is given. You can apply this simple formula, that is Raoult's law. Vapor pressure is sum of vapor pressure of 2 components. Components vapor pressure will be PA0 XA and PB0 XB. And substituting the values 350 and 0.7, 0.3, 410 and 0.8 and 0.2, and calculation you will lead to the PA0, you will get 314 torr. The next question is based on kinetics. Here half-lives are given at different initial pressures. It is asked to calculate the order of the reaction. A routine question. We know that for nth order reaction, half-life is proportional to initial concentration or initial power 1 minus n, where n is the order of the reaction. Now from this we can write T half 1 upon T half 2 is equal to P naught 1 by P naught 2 power 1 by 1 minus n. Take any two values, 2 upon 4, 100 upon 50. Substitute this, you'll get n is equal to 2. Second order we are getting. Now this is question based on physics option. Again directly NCRT statement. Physics option is highly specific in nature. This is wrong, because between the adsorbent and adsorbate there are only van der Waals force of attractions are there. Due to this van der Waals force of attraction, physics option is less specific. So less specific for the adsorbate, whereas chemis option is specific for the adsorbate because it should form the chemical bond. Physics option is monolayer in nature. Wrong. Physics option is multi-layer. Chemis option is monolayer because it can form chemical bond. After formation of chemical bond with one set species, it cannot form chemical bond with the other species in the same direction. So physics option is monolayer. Physics option has zero activation energy. This is correct because this is just van der Waals forces. It does not require any activation, whereas chemis option requires activation. Physics option decreases with increase in temperature. This is correct because the gas molecules which are adsorbed on the surface, so adsorption is generally exothermic in nature. As this has no activation energy, when you increase the temperature, the adsorbed gas molecule will be dissolved, removed from the metal surface. So physics option extent will decrease with increase in temperature. Physics option has high delta H adsorption. This is wrong. Physics option has low adsorption because it is weak van der Waals forces. This statement is correct if it is chemis option. Chemis option has high delta H adsorption. Now there is a question based on the thermodynamics. Work done is asked. Total work done is work done in this cyclic process is asked. So pressure and volume at two different points are given. Here total work is work AB plus BC plus CA. We can see that this A to B is isochoric process, P into delta V. So work done during the isochoric process is 0. B to C is isobaric process. We can write work done is minus P into V2 minus V1. C to A is an isothermal process. For isothermal process, we can write work done is minus RT ln V2 by V1. So for to calculate work done, here temperature is not given. We can calculate temperature at point C by using the expression PV is equal to nRT. Pressure is 1 atmosphere, volume is 20 liter, and moles of the gases are 1. Okay, so from this we can get the number of moles of gases. P is 1, V is 20 by R, 20 by R. So you can write the work done in BC, that is minus P into V2 minus V1. V2 is 20, V1 is V2 is 4. Sorry, V2 is B to C. V2 is 20, V1 is 40. And PV you can, or temperature value you can substitute, and V2 minus V2 upon V1 in this step is 40 upon 20. You calculate this, you'll get 6 liter atmosphere. We know that 1 liter atmosphere is 101.3 joules. So on calculation you'll get nearly 608 joules. The next question is, which of the following are the concentration terms? Concentration of a solution is expressed in different terms like mass percentage, correct, molality, correct, molarity, mole fraction, ppm, but not in moles. So this is a very simple question. Molarity, weight percentage, volume percentage, mole fraction, ppm are concentration terms. The next question is, unipositive ion of an atom containing 55 protons contains how many s electrons? You can write directly electronic configuration for 55 protons. 55 protons means it is cesium. If you don't know cesium also, you can directly write, no need to find which element, directly you can write here. That is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6, 6s1 cesium. If you remove the outer electron, this is becoming 5p6, 5s2, 5p6 in the valence shell. They are asking how many s electrons are there. S electron here 2 to 4, here to 6, 8, and these two are 10. So total 10 electrons are there. So the next question is, how many tripeptides can be formed from the amino acids valine and proline? This is very easy question. You can directly write this. There are two amino acids. They are asking tripeptides. So 2 power 3, 8 you will get. So we can write all valence, valine, valine, valine. One of them can be alanine. It can be a C terminal, or it can be at the middle, or it can be N terminal. So total 4. Similarly, we can write all alanines. One of them is valine. It can be N terminal or it can be C terminal or N terminal, or it can be in between. So here again we are getting 4. Total 8 tripeptides are possible. So this is the paper. We got here 26 questions. You can go through these questions and have some idea for the upcoming exam.